Listening practice, expansion of Chapter 1, transforming your outline into actionable content for readers, Part I, Foundations of Business Process Analytics 1. Introduction to Data-Driven Business Processes. Core thesis: business processes are no longer just workflows to execute tasks, they are rich data generators. Harnessing this data transforms operations from intuition-based to evidence-driven. 1.1 The evolution of business process management, BPM, pre-digital era, manual workflows, paper-based tracking, reactive problem solving. Automation wave, 1980s to 2000s ERP/SCM systems, linear process automation, focus on standardization, e.g., Six Sigma, data-aware BPM, 2010s integration of basic reporting, early dashboards, siloed analytics. Intelligent BPM, present AI/ML integration, real-time sensor data, IoT, predictive/prescriptive capabilities, continuous optimization. Key shift, from doing processes to learning from processes. 1.2 Synergy between data analytics and BPM, data as the process mirror, process mining, reconstructing actual workflows from event logs, versus assumed maps. Digital twins, creating dynamic virtual replicas of physical processes for simulation. Closing the loop, observe, descriptive analytics, diagnose, diagnostic, predict, predictive, act, prescriptive, automate, RPA/AI. Breaking silos, unifying data from CRM, customer, ERP, operations, HR systems for end-to-end visibility. 1.3 Key benefits: efficiency, innovation, competitive advantage. Benefit: how data analytics delivers real-world example efficiency, 15 to 25% cycle time reduction via bottleneck identification, process mining. BR, 20 to 30% cost savings via predictive maintenance, ML. Siemens, reduced factory downtime by 15% using sensor-driven maintenance. Innovation, discovering hidden process patterns enabling new products/services. BR, A/B testing process variations at scale. Netflix, data-driven content production workflow reducing launch risk. Competitive edge, real-time dynamic pricing and inventory optimization. BR, hyper-personalized customer journeys increasing retention. BR, faster regulatory compliance via automated audits. Amazon, algorithmic repricing of 2.5M and items daily based on demand/supply data. Why this matters now: companies leveraging process analytics achieve 5-6x higher customer satisfaction and 30% higher operational efficiency than peers. McKinsey, 2024, the new imperative: in the age of AI, data isn't just supporting processes, it's redefining them. Organizations ignoring this fusion risk obsolescence. Chapter 1 Takeaways: 1. BPM has evolved from standardization to autonomous optimization. 2. Analytics transforms BPM from a static discipline into a dynamic learning system. 3. Tangible ROI is achieved through efficiency gains, innovation enablement, and market agility. 4. Data is the new control tower for business operations. This chapter sets the stage by arguing that data analytics isn't an add-on to BPM, it's the central nervous system of modern operations. The following chapters dive into the how. Here's a detailed, actionable expansion of Chapter 2 for practitioners and students. 2. Core concepts of business process data. Core thesis: process data is the digital exhaust of operations. Capturing, structuring, and interpreting it unlocks actionable intelligence. 2.1 Types of process data. Data type characteristics. Use cases. Examples. Operational high volume, time-stamped, machine-generated. Bottleneck detection, SLA compliance. Sensor readings, server logs, machine uptime. Transactional. Structured, event-driven, financial/legal relevance. Audit trails, compliance. Reporting. Purchase orders, invoice approvals, payment records. Customer. Unstructured/semi-structured, behavioral journey optimization, churn prediction support tickets, clickstream data, NPS surveys, contextual external, environmental factors, risk forecasting, demand planning, weather data, market indices, social trends, critical insight, combining transactional and customer data reveals why processes fail, e.g., payment delays occur when customers 60 years old submit paper invoices. 2.2 Data sources, from legacy to real-time enterprise systems, ERP, SAP/Oracle financials, inventory, procurement, CRM, Salesforce lead-to-cash cycles, service requests, HRIS, Workday recruitment, payroll, performance data. B. Emerging sources, IoT sensors, equipment vibration, temperature, GPS telemetry, unstructured data, emails, NLP, call transcripts, speech analytics, API ecosystems, social media, partner systems, public datasets. See legacy system challenges, data silos, e.g., mainframe cloud integration, schema mismatches, field naming inconsistencies, latency issues, batch versus real-time streams, data integration rule, map event logs. First, 85% of process insights come from timestamped actions, e.g., order_created, payment_received. 2.3 Metrics and KPIs for process performance. The process analytics hierarchy, mermaid graph. TDA efficiency. B. Cycle time, AC, process cost, D. Quality. E. Error rate, DF, first pass yield, G. Flexibility. H. Changeover time, GI, variant handling capacity. Top 10 universal process KPIs, 1. Cycle time, start to end duration, target, reduce by 15% quarterly. 2. Throughput, units processed/hour, e.g., 200 loan apps/day. 3. Cost per transaction, labor and tech and overhead. 4. Conformance rate, percent steps following compliance rules. 5. Rework rate, percent outputs requiring correction. 6. Resource utilization, human/machine capacity usage. 7. Customer wait time, queue duration, e.g., call centers. 8. Escalation rate, percent cases needing supervisor intervention. 9. Automation rate, percent touchless transactions. 10. Predictive accuracy, forecast versus actual variance, MAPE, KPI pitfall alert, avoid vanity metrics, e.g., high throughput with low conformance equals defective outputs. 2.4 Data quality framework, non-negotiable. Accuracy, does data reflect reality? Validate via spot audits. Completeness, missing fields cripple event log analysis. Timeliness, stale data equals outdated insights. Set freshness SLAs. Consistency, uniform units/formats across sources. Granularity, transaction level aggregated data. Fix strategy, automated validation rules plus data lineage tracking, e.g., Apache Atlas. Chapter 2 Takeaways. 1. Process data is multimodal blend operational, transactional, and customer data. 2. IoT and APIs are revolutionizing real-time process visibility. 3. KPIs must balance efficiency, quality, and flexibility. 4. Garbage in equals garbage out, invest in data quality upfront. Without trustworthy data, process analytics is astrology, not science. Next, Chapter 3 explores how to transform this data into insights using descriptive analytics. Part 2, Analytical Techniques for Process Optimization. 3. Descriptive Analytics, Understanding Process Performance. Core Thesis, Descriptive Analytics turns raw process data into visual narratives, exposing hidden patterns and inefficiencies that traditional reports miss. 3.1 Visualization Tools, Seeing Your Processes. A process mining, what it does, reconstructs actual workflows from digital event logs, versus assumed maps. Key outputs, process discovery map, visual flow of all process variants, conformance check, compliance versus designed process, variant analysis, frequency of different paths, Tools, Celanese, UiPath Process Mining, Disco B Interactive Dashboards, Critical Components, Real-Time KPI Gauges, Cycle Time, Throughput, Heat Maps of Bottleneck Locations, Trend Lines with Anomaly Detection, Tools, Power BI, Tableau, ClickSense Rule of Thumb. If it takes 5 clicks to find a bottleneck, your visualization is failing. 3.2 Identifying bottlenecks and inefficiencies. The bottleneck detection framework. 1 Map the as-is process. Use process mining to capture reality. 2 Measure activity metrics, wait time, queuing, active time, value-adding work, handoff count. 3 Spot red flags, activities with 30% wait time, steps with high rework loops, resources consistently 85% utilization. 4 Quantify impact, cycle time extension equals, bottleneck processing rate, upstream input rate, cost of delay equals, bottleneck duration, times, hourly operational cost, common inefficiency patterns, pattern visual clue solution. Convergence point. Many flows merging into one step. Parallelize tasks or add resources. Repetitive rework. Closed loops in process map. Error proof inputs at origin. Priority inversion. Urgent tasks waiting behind routine. Implement triage queues. 3.3 Case study, reducing cycle time in manufacturing. Client, global automotive supplier. Problem, 34-day average order to ship cycle. Industry benchmark, 21 days. Descriptive Analytics approach. 1 Process mining, discovered 47% of orders took a detour through engineering review unnecessarily, identified 22-minute average wait time for quality sign-offs. 2 Dashboard tracking, real-time OEE, overall equipment effectiveness, revealed paint shop was bottleneck, 63% utilization versus target 85%. Heat map showed 3-4 p.m. daily throughput dropped 40%. Solutions implemented, eliminated non-value-added engineering review for standard orders, implemented mobile approval system cutting sign-off wait time to 2 minutes, shifted maintenance schedules to avoid 3-4 p.m. productivity dip. Results, markdown metric before after change. Average cycle time 34 days 19 days 44% on time delivery 76% 95% 25% labor costs / unit $18.70 $15.20 19% The Descriptive Analytics Workflow. 1 Extract, pull event logs from ERP/MES systems. 2 Transform, clean and map to process steps. 3 Visualize, build mining models and dashboards. 4 Diagnose, run bottleneck analysis, Pareto, funnel. 5 Act, prioritize improvements with highest cycle time impact. Avoid this mistake, don't just visualize, annotate. Always add context like QC wait time spike during shift changes to explain patterns. Chapter 3 Takeaways. 1 Process mining reveals the truth about how work actually happens. 2 Bottlenecks hide in handoffs and wait states, not just slow activities. 3 Dashboards must be actionable with drill-down capabilities. 4 The goal isn't pretty charts, it's finding the 20% of fixes that yield 80% of gains. Descriptive Analytics is the flashlight in the dark warehouse of your operations. You can't improve what you can't see. Next, Chapter 4 dives into Diagnostic Analytics to uncover why bottlenecks occur. Part 2, Analytical Techniques for Process Optimization. 4 Diagnostic Analytics, Root Cause Analysis. Core Thesis: Diagnostic Analytics moves beyond what happened to uncover why process failures occur, turning symptoms into actionable fixes. 4.1 Drill Down Techniques for Process Failures. The Root Cause Identification Framework, Mermaid Graph. LRA Symptom: B Data Segmentation, BC by Time, BD by Location, BE by Operator, CF Peak Hours, DG Specific Branch, EH Experience Level, FI Root Cause, GIHI Proven Methods, Stratification, split data into cohorts, e.g., errors by shift, day equals 12% versus night equals 43%, 5 Whys Technique, Problem, Invoice processing delays. Why? QC team rejects 25% of invoices. Why? Mismatched PO numbers. Why? Manual data entry from paper forms. Root cause, lack of digital PO integration. Time-based analysis, compare failure rates pre/post events, e.g., system updates, policy changes. 4.2 Correlation versus causation in process flaws. The critical distinction, correlation causation -- when sales reps skip CRM logging, deal closure rates drop *, forcing CRM logging increases closures by 17%. Traps to avoid. Third variable fallacy, observation, high overtime correlates with errors. Reality, understaffing, not overtime, causes both. Simpson's paradox, example, a process improvement appears to reduce defects overall, but increases them in every subgroup when segmented by product line. Causation test checklist, 1. Temporal precedence, cause precedes effect. 2. Covariation, change in cause, change in effect. 3. Eliminate confounding variables, control groups/experiments, data reality, correlation hints, causation demands intervention. 4.3 Essential root cause analysis tools. A fishbone diagram, Ishikawa, how to build it, markdown problem, 30% order processing delays, people untrained, temps methods, legacy approval flow, machines, printer jams, materials missing, SKU labels. Tip, combine with data, e.g., overlay delay frequency on each bone. B. Pareto analysis steps, 1. Tally process failure reasons, e.g., 100 order delays, missing docs, 50, system crashes, 30, credit checks, 15, other, 5. 2. Plot cumulative impact, missing docs, 50%, system crashes, 80%, vital few, 80% of delays, credit checks, 95%, other, 100%, rule, focus resources on the left. 20% of bars causing 80% of problems. See failure mode and effects analysis, FMEA, quantify risks, risk priority number equals severity times occurrence times detection. Example, unvalidated customer data, severity equals 8, occurrence equals 7, detection equals 2, RPN equals 112. Case study, fixing hospital discharge delays problem, 40% of patients discharged 2+ hours past target. Diagnostic process, 1. Pareto analysis revealed, 62% delays, pharmacy unavailability, 23% delays, transport delays. 2. Fishbone drill down on pharmacy delays, people, understaffed during shifts, process, manual prescription validation, technology, no real-time inventory alerts. 3. Causation test, ran pilot, automated inventory alerts reduced pharmacy delays by 68%. Result, discharge compliance improved from 60% to 89% in 4 months. Diagnostic workflow, from noise to signal. 1. Define the problem, quantify deviation, e.g., SLA breaches up 200%. 2. Segment the data, slice by time/location/resource. 3. Apply RCA tools, Fishbone, Pareto, FMEA. 4. Validate causality, A/B test solutions. 5. Implement controls, alerts, automation, training. Pro tip, beware of shallow causes. Dig until you hit a controllable factor, e.g., supplier unreliability isn't root cause, no backup supplier is. Chapter 4 Takeaways, 1. Root causes hide in data segments. Never analyze aggregates alone. 2. Correlation is not equal to causation, validate with controlled experiments. 3. Fishbone/Pareto turn qualitative hunches into data-driven priorities. 4. Diagnostics isn't about blame, it's about designing failure-proof systems. Fixing symptoms is firefighting. Fixing root causes is engineering. Next, Chapter 5 explores predictive analytics, forecasting failures before they occur. Part 2, Analytical techniques for process optimization. 5. Predictive analytics, forecasting process outcomes. Core thesis, predictive analytics transforms processes from reactive to proactive, anticipating failures, demand shifts, and opportunities before they occur. 5.1 Machine Learning for Demand Forecasting and Risk Prediction Key Models and Applications, Business Process ML Technique Input Data Output Demand Forecasting LSTM Neural Networks Historical Sales, Seasonality, Promotions SKU Level Demand, 95% Accuracy, Credit Risk Gradient Boosting, XGBoost, Transaction History. Behavioral Data Default Probability Score Inventory Optimization Sarima Models Lead Times, Supplier Delays, Sales Trends Safety Stock Level Recommendations Fraud Detection Anomaly Detection, Isolation Forest, User Behavior Patterns, Location Data Real-Time Transaction Risk Flags Real-World Impact, Walmart reduced forecasting errors by 30% using LSTM networks incorporating weather/social trends. American Express cut fraud losses by 25% with behavior-based ML models. Model pitfall: forecasts are wrong but good models quantify uncertainty. Always track mean absolute percentage error, MAPE, and prediction intervals. 5.2 Predictive Maintenance in Operations. The PDM workflow, Mermaid Graph LRA IoT sensors B, real-time data streams, BCML engine CD failure probability score DE maintenance alert CF remaining useful life estimate top techniques, 1 vibration analysis, data, 3 axis accelerometer readings, model, Fourier transform spectral feature extraction random forest classification, accuracy, 92% fault detection in bearings 2. Thermal anomaly detection, data, infrared camera feeds, model, convolutional neural networks, CNNs, use case, electrical panel hotspot identification 3. Acoustic monitoring, data, ultrasonic microphones, model, autoencoders for anomaly detection, impact, 40% reduction in unplanned downtime at Shell refineries ROI calculation, cost avoided equals, downtime costs/hour times MTTR reduction, plus, parts savings, sensor/ML costs, example, chemical plant saved $1.2 m/year preventing 8 compressor failures. 5.3 Scenario Modeling for Decision Support Monte Carlo Simulation for Process Risk, Steps, 1. Define variables with uncertainty, e.g., material costs plus or minus 15%, demand plus or minus 25%. 2. Build process model, e.g., order to cash cycle. 3. Run 10,000 plus simulations varying inputs. 4. Analyze output distribution, Python number sample output, delivery time simulation mean equals 18.2 days 90% confidence interval equals 15.1, 22.7 p, delay 25 days, equals 12.3% number high risk scenario digital twin applications, industry simulated scenario business decision aerospace supply chain disruption safety stock buffer optimization healthcare patient surge prediction staffing / resource allocation retail new store layout impact on checkout capital investment justification tool stack, Python, SciPy, SymPy, AnyLogic, Microsoft Azure Digital Twins case study, predictive maintenance in wind energy client, Vestas Wind Systems Challenge, turbine failures causing $15K/hour downtime. Solution: 1 fitted 4,000 plus turbines with vibration/temperature sensors. 2. Trained gradient boosting model on 2 TB failure history data. 3. Created digital twins for stress testing under hurricane conditions. Results: 87% accuracy in predicting failures 14 days in advance, maintenance costs reduced by 23%, energy output increased by 9% via optimized turbine settings. Predictive Analytics Implementation Guide Phase 1, Data Foundation, ensure temporal consistency, timestamps aligned across systems, store raw data not just aggregates, enables feature engineering. Phase 2, Model Development Mermaid Flowchart TBA feature. Engineering B Baseline Model BC Hyperparameter Tuning CD Backtesting DE Deployment Phase 3, Operationalization, Monitoring, Track Model Drift, e.g., Kolmogorov-Smirnov test, Feedback Loop, Human Override Logging, e.g., technician ignored alert Y. Hard truth, if your model isn't retrained weekly with new data, it's becoming obsolete daily. Chapter 5 Takeaways. 1. Demand forecasting requires both internal data and external signals, weather, social trends. 2. Predictive maintenance ROI comes from avoiding downtime, not just part savings. 3. Scenario modeling quantifies unknown unknowns through probabilistic simulation. 4. Prediction is power, but only if integrated into operational workflows. The best predictive model is worthless if the maintenance team doesn't trust its alerts. Next, Chapter 6 explores prescriptive analytics, turning predictions into automated actions. Part 2, Analytical techniques for process optimization. 6. Prescriptive Analytics, optimizing process decisions. Core thesis: Prescriptive Analytics transforms predictions into automated actions, combining AI, constraints, and business rules to make optimal decisions in complex environments. 6.1 Algorithmic recommendations for resource allocation. Mathematical foundations: linear programming, objective, maximize output, e.g., revenue, constraints, labor hours, budget, capacity. Example: nurse scheduling in hospitals. Reinforcement learning: agent learns optimal paths through reward feedback. Python number warehouse picking optimization: reward equals time_spent plus 10, order_completed, agent learns shortest pick paths. Industry applications, domain problem algorithm. Impact retail staff scheduling. Genetic algorithms: 22% labor cost reduction. Transport fuel optimization. Dynamic programming: 14% fuel savings. UPS Orion, manufacturing machine task assignment. Hungarian algorithm: 30% throughput increase. Healthcare operating room allocation constraint optimization: 18% more surgeries/month. Implementation tip: start with rule-based systems before full AI, e.g., prioritize VIP customers during shortages. Provides immediate value while training models. 6.2 Simulation and what-if analysis. Digital twin architecture: Mermaid Graph LRA, real-world process. B sensors. BC digital twin. CD simulation engine. DE what-if scenarios. EF prescriptive actions. FA key simulation types: 1. Discrete event simulation, day, models. Queues, wait times. Resource contention, use case, call center staffing during peak hours. 2. Monte Carlo risk analysis, quantifies uncertainty in process outcomes, use case, supply chain disruption planning. 3. Agent-based modeling, ABM, simulates autonomous agents, customers, employees, use case, store layout optimization for foot traffic. What-if framework: 1. Define decision levers, e.g., plus 20% staff, minus 15% inventory. 2. Set constraints, budget, regulations. 3. Run 10,000 plus simulations. 4. Analyze trade-offs, mark down scenario cost. Cycle time risk current $1.2 million 14 days. High plus automation $1.5 million 8 days. Medium plus buffer inventory $1.4 million 12 days. Low 6.3 Real-time optimization in supply chains. Dynamic control tower technology, Mermaid Graph. TB IoT sensors. B real-time data. BC optimization engine. CD prescriptive actions. DE autonomous execution. EF continuous learning. Cutting-edge applications: 1. Dynamic routing, input, traffic, weather, fuel prices, output, optimal delivery routes, updates every 90s. Example, Maersk reduced transit times by 16%. 2. Automated procurement, rules: if commodity price $X and inventory Y by, AI layer, predicts supplier reliability risks. 3. Self-optimizing warehouses, sensors, RFID, computer vision, actions, robot repositioning, dynamic pick paths, predictive restocking optimization. Metrics: freight cost per unit, perfect order rate, cash-to-cash cycle time. Case study: Amazon's prescriptive fulfillment challenge, balance 300 and SKUs across 200 fulfillment centers with one-day delivery promise. Solution: One real-time prescriptive engine considers inventory positions, demand forecasts, transportation costs, outputs, optimal warehouse to customer assignments. 2. Dynamic repricing adjusts prices based on real-time stock levels, competitor pricing, shipping cost fluctuations. 3. Autonomous execution algorithms directly trigger inventory transfers, robot swarm coordination, delivery route updates. Results: 40% reduction in fulfillment costs, 99.9% on-time delivery rate, $0 wasted storage, just-in-time positioning. Implementation roadmap. Phase 1, Foundation, map decision points in processes, e.g., approval thresholds, create digital twin of core workflows. Phase 2, Optimization Mermaid flowchart. LRA define objectives. B identify constraints. B C build mathematical model. C D validate with historical data. Phase 3, Autonomy, start with low-risk decisions, e.g., inventory reordering, implement human-in-the-loop oversight initially, monitor with decision compliance rate, algorithm versus human performance, ROI per prescriptive action. Critical success factor: prescriptive systems require clean, real-time data latency. 5 minutes can cause catastrophic decisions. Chapter 6 Takeaways. 1. Resource allocation uses. Mathematical optimization, LP, RL, to maximize output within constraints. 2. What if analysis quantifies trade-offs before making costly changes. 3. Real-time supply chain optimization requires IoT and cloud and AI integration. 4. Prescriptive analytics shifts from what should we do, to the system already did it. Optimization is no longer a quarterly exercise, it's a continuous autonomic function. Next, Part 3 explores industry-specific applications of process analytics. Part 3, Industry Applications. 7. Supply Chain and Logistics Analytics. Core thesis: modern supply chains are neural networks of data. Analytics transforms them from cost centers to competitive weapons. 7.1 Inventory optimization using predictive models. The multi-echelon optimization framework: Mermaid graph. LRA demand forecast. B safety stock calculation. B C replenishment logic. C D automated order triggers. Advanced techniques: probabilistic stock modeling, safety stock equals Z times sigma underscore LT times lead time, Z equals service factor, sigma underscore LT equals demand variability. Machine learning enhancements: incorporate 50 plus variables, weather, social sentiment, competitor moves. Walmart, reduced excess inventory by 32% using holiday tweet analysis, digital twins for simulation, stress test strategies against disruptions, e.g., port strikes, hurricanes. Key metrics: inventory turnover ratio, target, 8 for retail, stockout rate, penalty, 65% of customers abandon after one stockout, obsolescence cost, high-tech, 12% revenue loss/year. 7.2 Route efficiency and delivery tracking. Real-time optimization engine, Mermaid graph. TBA live traffic. B optimization model. C weather. BD vehicle capacity. BE driver hours. BBF optimal route. FG driver app. GHEDA updates. AI driven innovations. 1 Dynamic rerouting, FedEx, saves 10 m gallons/year fuel with real-time detours, algorithm, Dijkstra's and live incident feeds. 2. Crowdsourced delivery, Uber Eats model, match delivery density with driver availability. 3. Autonomous checkpoints, computer vision and IoT sensors at docks, automated loading verification, damage detection, 97% accuracy, performance dashboard, KPI industry benchmark. Impact of optimization miles per delivery. 8.2, urban, 22% with cluster routing. Fuel cost per mile 68 cents. 18% with eco routing. On-time delivery 95% to 99% with live EDA. 7.3 Supplier risk analytics. Risk quantification framework, total risk score equals, financial health times 0.4, plus, geopolitical risk times 0.3, plus, performance history times 0.3, data-driven assessment, 1. Financial viability, scrape 10K filings with NLP Altman Z-score prediction. 2. Geopolitical threats, machine learning risk map, Python risk _score equals 0.2, conflict _index, plus 0.5, port congestion, plus 0.3, trade tariff, 3. Operational resilience, IoT monitoring of supplier facilities, energy usage production inference, early warning system architecture, Mermaid Graph LRA supplier DBB risk scoring engine C News APIs BD financial markets BBE alert dashboard EF automated contingency case, Toyota tsunami preparedness, monitored 500 plus suppliers with seismic sensors, AI predicted component shortages within 15 minutes of 2024 Japan quake, switched production via pre-negotiated backup contracts, $0 lost sales - supply chain control tower in action Unilever's digital nerve center, 1 data integration, 200 plus ERP systems unified data lake. 2. Prescriptive Analytics, autonomous raw material buying during price dips. 3. Blockchain traceability, palm oil journey from farm to factory, compliance proof, results, 28% reduction in logistics costs, 99.97% ESG compliance audit score, 15-minute crisis response time - implementation checklist. Phase 1, Visibility Foundation, instrument all nodes with IoT sensors, map Tier 1 to Tier N suppliers, implement real-time tracking, RFID/GPS. Phase 2, Predictive Layer, build demand sensing models, internal and external data, train supplier risk classifiers, create digital twin for simulations. Phase 3, Autonomous Response, connect analytics to execution systems, e.g., WMS, TMS, set rules, if risk _score 85 trigger backup order, implement blockchain for audit trails pitfall alert, don't chase perfect data, start with 80% complete data and iterate. Delayed analytics costs more than imperfect analytics. Chapter 7 Takeaways. 1. Inventory optimization requires probabilistic modeling, not just historical averages. 2. Route efficiency gains come from second-by-second recalculations. 3. Supplier risk equals financial plus operational plus geopolitical factors. 4. Future supply chains compete on algorithms, not assets. The most valuable supply chain asset is no longer warehouses, it's the data scientists optimizing them. Next, Chapter 8 explores customer-centric process analytics. Part 3, Industry Applications. 8. Customer-centric process analytics core thesis, customer journeys are the new balance sheets. Analytics turns touchpoints into profit engines and churn into growth. 8.1 Customer Journey Mapping with Data. The Digital Footprint Framework, Mermaid Journey. Title: Customer Journey DNA Section: Awareness Google Search, 45%, Social Media, 30%, Section: Consideration Website Visit, 22%, Product Demo, 8%, Section: Purchase Cart Abandonment, 62%, Checkout, 38%, Section: Loyalty Support Ticket, 15%, Repeat Purchase, 7%, Advanced Mapping Techniques, 1. Event Stream Clustering, group customers by behavioral patterns, e.g., research-intensive buyers. Tool, Apache Kafka and K-means clustering. 2. Pain point quantification, Python frustration _score equals, page exits times 0.3, plus, support contacts times 0.5, plus, negative sentiment times 0.2, 3. Channel attribution modeling, algorithmic assignment of conversion credit, Shapley value, game theory, Markov chains. Real-world impact, Sephora identified 3 hidden drop-off points in VIP onboarding, 28% conversion lift. Delta Airlines reduced call volume 40% by fixing app pain points found in journey maps. 8.2 Churn prediction in CRM processes. The churn risk engine, Mermaid Graph. TBA usage frequency. B churn model. C support tickets. BD payment delays. BE sentiment analysis. BBF risk score. FG retention playbook. Predictive features that matter, High impact, low impact, login frequency, 30% demographic data, feature usage, diversity, company size, peer cohort comparison, subscription tier, support, sentiment, tenure, paradoxical, intervention strategies by risk tier, risk level, action, costs / result high, 80 to 100%, dedicated manager plus custom offer $250 customer, 45% save rate, medium, 50 to 79%, success webinar plus feature training $75 customer, 65% save rate, low, 0 to 49%, automated winback email sequence $5 customer, 15% save rate, case study, Salesforce reduced enterprise churn by 22% using NLP on support tickets, anger equals 8x churn risk, usage gap alerts, customer hasn't used paid feature X in 14 days, 8.3 personalization in marketing funnels, hyper-personalization architecture, Mermaid Graph LRA, behavioral data B, real-time profile C, contextual data B, AI engine DE, personalized content DF, predictive offer DG, channel optimization, proven tactics by funnel stage data trigger, personalized action top funnel content consumption pattern, recommend related assets, e.g., like X, read Y, mid-funnel feature engagement gaps, targeted demo invitation, bottom funnel cart abandonment plus price sensitivity, dynamic discount with countdown timer, post-purchase usage frequency plus feature depth, proactive upsell, teams using X save 3H/weak technology stack, CDP, segment, Telium, real-time decision engines, Adobe Target, Optimizely, Predictive Analytics, H2O.ai, DataRobot, ROI metrics, personalization lift, revenue increase equals, personalized conversion rate, baseline rate, times AOV times traffic, cost of generic marketing. Unpersonalized emails have 0.15% CTR versus 3.2% for behavioral triggered emails. The omni-channel optimization cycle 1. Capture, unify data across web, app, email, support, IoT. 2. Analyze, build 360 degrees customer view with lifetime value prediction, next best action modeling. 3. Activate, automate personalization in dynamic website content, chatbot dialogues, sales playbooks. 4. Measure, attribute revenue to touchpoints with media mix modeling, MMM, multi-touch attribution, MTA, compliance essential. Personalization requires consent architecture, preference centers must be as sophisticated as your recommendation engines. Case study, Netflix's recommendation engine, the personalization machine, 1 data inputs, 2,500 plus viewer attributes per account, microgenre preferences, 76,897 categories. 2. Algorithm, collaborative filtering and deep learning, real-time A/B testing, 250 plus tests/month. 3. Business impact, 80% of watched content from recommendations, $1B and annual savings in reduced churn. Implementation roadmap, phase 1, foundation, implement event tracking plan, snowplow/GA4, build customer data platform, CDP, create single customer view. Phase 2, intelligence, develop churn prediction model, map high-value journey segments, train next best action engine. Phase 3, automation, connect analytics to marketing automation, launch real-time personalization, establish closed-loop measurement. Truth, generic marketing is now a tax on stupidity. Personalization isn't optional. Chapter 8 Takeaways. 1. Journey mapping reveals hidden revenue leaks in digital touchpoints. 2. Churn prediction must trigger automated retention workflows. 3. Personalization drives 5-8x ROI through relevance. 4. Customer analytics shifts marketing from spray and pray to predict and perfect. Customers don't expect personalization, they demand it as the price of engagement. Next, Chapter 9 explores financial process analytics. Part 3, Industry Applications. 9. Financial Process Analytics Core Thesis: Financial operations are evolving from backward-looking reporting to AI-driven foresight where fraud prevention, automation, and forecasting converge as strategic assets. 9.1 Fraud Detection in Transactional Processes. The AI Defense Architecture, Mermaid Graph TB. A transaction stream. B real-time scoring engine. B low risk. C approve. B high risk. D block and alert subgraph. AI models. B E anomaly detection. B F network analysis. B G behavioral biometrics and advanced techniques. Fraud type detection method. Key features payment fraud isolation. Forest velocity checks. Mismatched device/IP invoice scams. Graph neural networks. Supplier customer relationship mapping. Account takeover. Behavioral biometrics. Keystroke dynamics. Mouse movements. Money laundering. Temporal link analysis. Layering patterns. Circular transactions. Real-time defense metrics. False positive rate. Industry average 15:1. AI reduces to 3:1. Detection speed 87 milliseconds. Average decision time. Prevention ROI $13 saved per $1 invested in AI fraud. Tech case study: PayPal's AI defense processes 1.1 M transactions/hour, reduced fraud losses by 50% using ensemble models, XGBoost and deep learning. Real-time consortium data sharing. False positives down 54%. Saved $755 M/year in customer friction. 9.2 Automated invoice processing, RPA and NLP, the touchless processing workflow. Mermaid Journey. Title: Invoice Processing Automation. Section Capture OCR and Computer Vision, 99% accuracy. Section Extraction NLP. 4 line items, 95% precision. Section Validation. 3-way matching, PO, GRN, invoice. Section Approval. AI routing based on rules. Section Payment. Blockchain ledger update. Technology stack. Component tools. Innovation data capture. ABI, Google Vision AI. Handwritten field recognition. NLP. Extraction. Spacey, Amazon Textract. Context aware line item parsing. Validation. Smart contracts, Ethereum, immutable 3-way matching. Integration. RPA, UiPath, automation anywhere, ERP. Auto posting, SAP/Oracle, ROI calculation, markdown metric. Manual automated improvement. Processing cost $12.90 $2.30 82% cycle time 23 days 4 hours 99% error rate 18% 0.5% 97% early payment discount capture 12% 89% 642% 9.3 Cash flow forecasting. The predictive treasury framework, Mermaid Graph. LRA historical data. BML forecast engine. C market signals. BDAP/AR pipelines. BBE scenario modeling. EF liquidity recommendations. Machine learning models in action. 1 AR prediction, LSTM networks. Forecast payment dates, accuracy, plus or minus 1.8 days, features, customer payment history, industry risk scores. 2. AP optimization, reinforcement learning for dynamic discounting. Discount equals F, cash position, supplier criticality, cost of capital. 3. Liquidity scenarios, Monte Carlo simulations for 30-day cash positions, Python number output, probability distribution P, cash $5 million, equals 12% trigger credit line P, cash $10 million, equals 34% invest in short-term bonds. Enterprise impact, Siemens reduced cash buffer requirements by $1.2 billion using ML forecasts. Unilever improved forecast accuracy from 78% to 96%. Saved $45 million in financing costs. Case study, JP Morgan Chase's Coin Platform Challenge, manual review of 12,000 annual commercial loan agreements, 360K hours. Solution, 1 NLP engine, extracts 150 plus data points from contracts, rates, covenants. 2. Blockchain validation, smart contracts flag discrepancies in real time. 3. Cash flow simulation, predicts borrower default risk under recession scenarios. Results, review time reduced from 360K 12 hours/year, default prediction accuracy, 94%, versus 78% human, released $1.4 billion capital through optimized reserves. Implementation checklist. Phase 1, fraud defense, implement real-time transaction monitoring, build behavioral biometrics profiles, join industry fraud consortiums. Phase 2, invoice automation, digitize paper invoices, mobile capture. Train NLP models on document history, integrate RPA with ERP payment runs. Phase 3, forecasting excellence, consolidate cash data from all entities, develop ML models with 30+ external signals, create liquidity war room with scenario dashboards. Compliance critical, financial analytics must bake in GDPR/HIPAA/PCI-DSS. Anonymize data at ingestion, not as an afterthought. Chapter 9 Takeaways. 1. Modern fraud detection combines AI, network analysis, and behavioral biometrics. 2. Invoice automation delivers 80% plus cost reduction through RPA and NLP and blockchain. 3. Cash flow forecasting shifts from spreadsheets to ML-driven scenario planning. 4. Financial analytics transforms CFOs from historians to futurists. In finance, every second of latency costs money and every false positive costs customers. Next, Chapter 10 explores HR and operational analytics. Part 3, Industry Applications. 10. HR and operational analytics. Core thesis: human capital is the ultimate competitive advantage. Analytics transforms HR from administrative support to a strategic profit center by optimizing productivity, talent, and safety. 10.1 Employee productivity and workflow analysis. The Productivity Intelligence Framework, Mermaid Graph. TBA digital footprint. B. Productivity scoring. C. Workflow patterns. BD output quality. BBE optimization insights. Key metrics and techniques, metric measurement method optimization levers. Focus time. App usage and calendar analysis. Meeting reduction, focus blocks. Collaboration. Load network analysis, Slack/Teams, restructure reporting lines. Task switching. Cost screen monitoring and ML batch. Similar tasks. Deep work ratio. Uninterrupted work sessions eliminate low value notifications. Microsoft's productivity lab findings: employees spend 57% time on coordination, not core work, 3+ hours/day recovered by reducing meetings 30 minutes, implementing no internal email Fridays, using AI for priority filtering. AI-driven workflow optimization, process mining, identifies redundant approvals, e.g., 5-step 2-step, reinforcement learning, recommends optimal task sequences based on cognitive load. 10.2 Talent acquisition process optimization. The AI recruiting engine, Mermaid journey. Title: data-driven hiring pipeline. Section: sourcing. AI resume screening, 10x speed. Section: assessment. Gamified skills testing. Section: interview. NLP sentiment analysis. Section: offer. Predictive acceptance modeling. Revolutionary technologies. 1. Predictive sourcing, LinkedIn graph analysis. Find passive candidates with 92% role match. 2. Bias elimination, Textio, rewrites job posts to increase diversity, 37% more female applicants. 3. Interview intelligence, HireVue, analyzes 15K linguistic/speech markers, predicts performance. 4. Offer optimization, P, accept, equals F, salary, remote flexibility, growth path, recruitment KPI dashboard, metric industry average top quartile time to hire 42 days 18 days cost per hire $4,683 $1,950 quality of hire 55% retention/year 82% retention/year diversity rate 28% 51% Unilever's digital hiring revolution replaced campus recruiting with AI assessments, results, 90% reduction in hiring time, 50% more diverse hires, $1.3 million annual savings. 10.3 Workplace safety and compliance monitoring, predictive safety architecture, Mermaid graph. LRA IoT sensors. B. Risk prediction. C. Computer vision. BD incident history. BBE real-time alerts. BF preventive actions. AI safety applications, 1. Computer vision hazard detection, PPE compliance monitoring, helmets, gloves, 99% accuracy, near miss identification, e.g., forklift proximity. 2. Environmental sensing, air quality and noise level analytics, automatic ventilation adjustment. 3. Ergonomic risk scoring, Microsoft Viva Insights, posture analysis via webcam, back injury prevention, compliance automation, smart contracts, auto document safety checks on blockchain, regulatory change AI, track 500 plus global compliance sources, alert impacted sites, audit robotics, automate 80% of ISO/OSHA documentation checks, Boeing safety transformation, implemented IoT wearables and computer vision across 12 factories. Results: 72% reduction in recordable incidents, $47 million annual workers' comp savings, automated 92% of FAA compliance reporting. The HR Analytics Maturity Model, Mermaid Graph LRA, Reactive Reporting B, Descriptive Analytics BC, Predictive Optimization CD, Prescriptive Automation Implementation Roadmap. Phase 1, Instrumentation, deploy productivity trackers, e.g., ActiveTrack, implement ATS with API ecosystem, install IoT safety sensors. Phase 2, Intelligence, build retention risk models, optimize recruitment funnels with ML. Develop safety prediction algorithms. Phase 3, Integration, connect HR analytics to operational systems, automate interventions, high burnout risk trigger reduced workload, safety violation predicted lock machinery. Ethical imperative, productivity monitoring must be transparent, employees own their data. Anonymized aggregation builds trust. Chapter 10 Takeaways. 1. Productivity analytics balances efficiency with sustainable work practices. 2. AI recruiting delivers faster, cheaper, and fairer talent acquisition. 3. Predictive safety prevents incidents before they occur. 4. HR analytics transforms people operations from cost center to value creator. The factory of the future has 2 employees, a human and a robot. The human's job is to keep the robot happy. Next, Part 4 explores implementation strategies for process analytics. Part 4, Implementation Strategies. 11. Building a data-driven process culture. Core thesis: technology enables analytics, but culture sustains it. Transforming organizations requires rewiring mindsets before systems. 11.1 Leadership alignment and change management. The executive playbook, Mermaid Graph TDA, create burning platform. B, secure sponsorship. B, C, define North Star metrics. C, D, model data-driven behavior. D, E, celebrate wins. Proven tactics: 1. Business case CO creation, jointly develop ROI projections with finance, e.g., 10% efficiency gain equals $2.8 million savings. 2. Executive data immersion, mandatory day in analytics where leaders explore process mining dashboards, validate predictive models. 3. Cross-functional governance, rotating analytics leadership between operations/finance/IT. Change management framework, ADKAR stage action tool awareness town halls showing as is process inefficiencies. Process mining heat maps. Desire pilot quick wins, e.g., 30-day automation sprint, RPA implementation. Knowledge leader certification in data literacy. MIT MicroMasters programmability. Embedded data champions in each department. Reinforcement bonus metrics tied to data-driven outcomes. Citizen developer training. OKRs with analytics weight. Pitfall alert: avoid analytics tourism when leaders request reports but ignore them. Combat this by requiring decisions to cite supporting data. 11.2 Data literacy training for teams. The 4-tier competency model, Mermaid Pi. Title: Data literacy pyramid. Data consumers, 60 data explorers, 25 data analysts, 10 data scientists, 5 customized learning paths. Role skills training format frontline KPI interpretation, dashboard basics. Microlearning, 5-min videos, managers. Diagnostic Analytics, A/B testing. Workshops and simulation labs. Specialists. SQL, process mining, basic Python. Cohort-based certifications. Leaders. Predictive ROI, ethics, governance. Executive roundtables. Innovative training tools, 1. Gamified learning, Data Quest, process optimization simulations, Analytics escape rooms, e.g., fix the bottleneck in 60 minutes. 2. Just-in-time upskilling, Google Looker's embedded coaching, hover over dashboard, see tutorial 3. Fluency assessment, Python number data literacy score algorithm score equals, tool_proficiency 0.4, plus, interpretation _skill 0.3, plus, ethical_judgment 0.3, Unilever's Data Academy impact, trained 45,000 employees in 18 months, results, 300% increase in self-service analytics, 22% faster decision velocity, 68% reduction in report requests to IT. The culture transformation dashboard, key metrics to track, cultural metric measurement method, target data trust index, employee survey, 1 to 5 scale, 4.2 decision evidence rate, audit meeting minutes for data citations, 85% experimentation velocity, number A/B tests run per quarter, 50+ citizen developer growth %, employees creating dashboards 15%, 40% case study, Microsoft's data culture revolution challenge, silos between engineering and business teams slowing AI adoption. Solution: 1. Leadership alignment. Satya Nadella mandated data stories in all board presentations, executives took public data literacy pledges. 2. Cultural interventions, 0 email Fridays for analytics deep work, gamified KPI leaderboards across teams. 3. Training ecosystem, required 80 hours/year data upskilling, internal marketplace for analytics mentors. Results: 90% of teams use predictive analytics daily, $19 billion incremental revenue from data-driven products, ranked number 1 in Gartner's Data-Driven Culture Index. Implementation roadmap. Phase 1, align, conduct analytics maturity assessment, secure CEO sponsorship with 3-year funding commitment, define 3 measurable cultural KPIs. Phase 2, equip, launch data literacy certification tracks, implement analytics assistant AI copilots, create recognition programs for data wins. Phase 3, embed, rewrite job descriptions to include data competencies, integrate analytics into performance reviews, establish ethics review boards for AI governance. Critical success factor, culture change requires 20% technology and 80% sociology, budget accordingly. Chapter 11 Takeaways. 1. Leadership must model data-driven behaviors daily, not just fund initiatives. 2. Data literacy training requires role-specific, just-in-time learning, not one-size-fits-all. 3. Cultural metrics, trust, experimentation rate, matter more than technical ones. 4. Sustainable analytics culture turns data consumers into data citizens. You can buy analytics tools in weeks, but growing data DNA takes years. Start now. Next, Chapter 12 covers technology stack selection for process analytics. Part 4, Implementation Strategies. 12. Technology Stack for Process Analytics. Core Thesis: your tech stack is the central nervous system of process intelligence. Strategic tool selection determines whether analytics remains a dashboard ornament or becomes an operational engine. 12.1 Tools Comparison, Process Mining versus Buy versus Automation Decision Framework, Mermaid Graph. TDA Business Need. B. Primary Objective. B. Discover actual processes. C. Process Mining. B. Visualize performance. D. Buy tools. B. Automate actions. E. RPA/IPA Tool Comparison Matrix, Capability. Process Mining. Buy tools. Automation platforms. Primary use: process discovery and conformance, KPI dashboards and reporting, task execution and integration. Key players: Celanese, UiPath. Process mining: Power BI, Tableau, Qlik. UiPath, automation anywhere, data handling, event logs, timestamped actions, aggregated metrics. UI and API interactions, AI integration, predictive process monitoring, NLP for natural language, Q&A, computer vision for screen scraping. Strengths: bottleneck identification, trend analysis, closed loop process execution, implementation cost $, with attended RPA, ROI time frame 3 to 6 months, 1 to 3 months, 6 to 12 months. Synergy strategy: Mermaid Flowchart LRA Celanese Process Insights B Power by B Anomaly Alert C UiPath Bot C Execute Fixes A Real-World Stack Examples, Siemens, Celanese, Process Mining, plus Azure ML, Predictive Maintenance, plus Power Automate, Workflow, Coca-Cola, UiPath Process Mining and Tableau Plus. Automation Anywhere, Invoice Processing, 12.2 Integrating AI/ML Platforms Unified Architecture, Mermaid Graph LRA Process Data B Data Lake BC Tool Integration CD Process Mining CE by Visualization CFML Platform FG Predictive Models GH Prescriptive Actions HIRPA Execution Platform Selection Guide, Requirement TensorFlow/PyTorch Azure ML/SageMaker Specialized Tools Best for Custom Deep Learning Models Enterprise ML Ops Lifecycle Domain Specific Solutions Process Use Case Computer Vision for QC Defects Predictive Maintenance ABI for Document Intelligence Integration Complexity High, Python Expertise Needed, Medium, Drag and Drop GUI, Low, Pre-built Connectors, Scalability Kubernetes Clusters Required Auto-scaling Managed Service Vendor Dependent Cost Profile Open Source and Infra Costs per Compute and Licensing per Transaction Fees Integration Patterns, 1 API First Design, Process Mining Tools Call ML Models via REST APIs, e.g., Celanese and DataRobot, 2. Embedded Analytics, Power by Embeds Azure ML Predictions in Dashboards 3. Event-Driven Automation, UiPath Bots Trigger on ML Model Alerts, e.g., Fraud Detection Block Transaction, 12.3 Cloud vs. On-Premise Solutions Decision Framework, Mermaid Flowchart TDA Data Sensitivity Regulated Industries B On-Premise A Flexibility Needed C Cloud D Scalability Needs Predictable Workloads B D Spiky Demand C EIT Skills Legacy Expertise B E DevOps Culture C Comparative Analysis, Factor Cloud, Azure/AWS/GCP, On-Premise Hybrid Implementation Speed Days/Weeks Month 6 to 12 weeks Upfront Cost Low, OPEX Model, High, CAPEX, Medium Scalability Instant Auto-Scaling Fixed Capacity Burst to Cloud Security Control Shared Responsibility Model Full Control Sensitive Data On-Prem Compliance Certifications, ISO/SOC, Custom Frameworks Split by Data Type AI/ML Access 100 Plus Managed Services Limited to Installed Tools Cloud for Training, On-Prem Inference Industry Specific Recommendations, Financial Services, Hybrid, Core Banking On-Prem and Cloud for Analytics, Manufacturing, Edge Computing for Real-Time and Cloud for Historical Analysis, Healthcare, Private Cloud with HIPAA-compliant vendors, e.g., Google Healthcare API, The Future-Proof Tech Stack 2025 Architecture Blueprint, Mermaid Graph BTA Edge Devices B Data Fabric BC Process Intelligence Layer C DAI Engine DE Action Orchestration EF Digital Workers Style A Fill Number FF9 Stroke number 333 Style B Fill Number CFF Stroke number 333 Style C Fill Number FCF Stroke number 333 Style D Fill Number 9 F9 Stroke number 333 Style E Fill Number F99 Stroke number 333 Style F Fill Number 99 F Stroke number 333 Components, 1 Data Fabric, Unified Access Layer, Databases, APIs, Streams, Tools, Tailend, Informatica, Azure Synapse 2. Process Intelligence, Process Mining and by and Task Mining, Tools, Celanese, Power by, Task Top 3. AI Engine, ML Ops Platform for Model Lifecycle, Tools, DataRobot, SageMaker, Vertex AI 4. Orchestration, Workflow Automation and Integration, Tools, Apache Airflow, Azure Logic Apps 5. Execution Layer, RPA and Intelligent Document Processing, Tools, UiPath, Automation Anywhere and ABI-Implementation Checklist Phase 1, Assessment, Audit Existing Systems, ERP, CRM, MES, Map Compliance Requirements, GDPR, CCPA, Calculate TCO for Cloud versus On-Prem Phase 2, Tool Selection, Choose Process Mining for Discovery, select BI for visualization, pick ML platform for predictions, decide RPA for execution. Phase 3, integration, implement data pipeline, ETL/ELT, configure API/webhooks between tools, build monitoring dashboard, latency, data quality. Phase 4, optimization, implement ML ops for continuous retraining, set up auto-scaling policies, conduct quarterly tech stack reviews. Vendor lock-in warning, favor open standards, SQL, REST APIs, over proprietary languages. Your Celanese PQL skills shouldn't become a liability. Chapter 12 Takeaways. 1. Process mining. BI for workflow discovery, BI process mining for trend visualization. 2. Cloud dominates for AI/ML scalability but hybrid rules in regulated industries. 3. Tool integration creates compound value, e.g., process mining insights trigger RPA fixes. 4. Your stack must balance technical capability with organizational DNA. Choosing tools without an integration strategy is like buying a Ferrari without roads. Impressive but useless. Next, Chapter 13 covers data governance and ethical considerations. Part 4, Implementation Strategies. 13. Data Governance and Ethics. Core thesis: data governance is the immune system of analytics, preventing regulatory fines, ethical disasters, and algorithmic failures that can cripple even the most advanced implementations. 13.1 Ensuring data quality and consistency. The Data Integrity Framework, Mermaid Graph. LRA Data Sources. B Validation Rules. BC Standardization. CD Enrichment. DE Continuous Monitoring. Critical Components, Pillar Tools and Techniques. Key Metrics Accuracy. Statistical Process Control, SPC, Percent Records Passing. Spot Checks. Completeness. Data Profiling. Tail End, Informatica, Null Value Rate by Field. Timeliness. Event Timestamps and Latency Monitoring. Data Freshness, Seconds/Minutes, Consistency. Master Data Management, MDM, Cross-System Variance Score. Lineage. Data Catalog, Collabra, Alation, End-to-End Traceability. Coverage. Automated Quality Workflow. 1. Ingestion Checks, Validate formats/ranges at pipeline entry. 2. Transform Rules, Standardize Units, Currencies, Time Zones. 3. Statistical Alerts, Flag Anomalies, e.g., sudden 50% data drop. 4. Continuous Scoring, Python DQ_score equals, accuracy 0.4, plus, completeness 0.3, plus, timeliness 0.2, plus, consistency 0.1, if DQ_score 90, trigger_data_steam_hold, Volkswagen's data quality journey, implemented automated validation across 12,000 sensors in factories. Results: 99.98% accuracy in emissions compliance data, $220 million saved in avoided regulatory fines, 40% faster analytics pipeline velocity. 13.2 Privacy Regulations in Process Data Compliance Architecture, Mermaid Graph. TB. A. Data collection. B. Privacy check. B. Personal data. C. Pseudonymization. C. D. Encrypted storage. B. Non-personal. E. Raw processing. D. F. Access controls. F. G. Audit logs. GDPR/CCPA requirements matrix. Requirement GDPR CCPA implementation consent opt-in and purpose specification opt-out of sale cookie banners and preference. Center's right to access 30-day response time 45-day response time automated DSAR portals data minimization collect only necessary data similar principle field level access controls deletion right to be forgotten delete upon request automated erasure pipelines penalties 4% global revenue $7,500 per intentional violation regular compliance simulation pseudonymization techniques 1 tokenization replace PII with random tokens e.g. Stripe. 2. Differential privacy, add statistical noise to datasets. 3. Homomorphic encryption, process data while encrypted, e.g., IBM HE layers, compliance ROI calculation, cost avoided equals, fine probability times penalty amount, plus, reputation damage estimate, compliance program cost, example, avoiding 1 GDPR fine pays for 7 years of privacy engineering. 13.3 Ethical AI in Automated Decision-Making. The Ethical AI Framework, Mermaid Graph TDA Algorithm Design B Bias Testing BC Human Oversight CD Impact Assessment DE Continuous Auditing Critical Risk Areas and Mitigations, Ethical Risk Detection Method Prevention Strategy Discrimination Disparate Impact Analysis Reweighing Training Data Opacity Explainability Scoring, SHAP/LIME, Interpretable Model Architectures Surveillance Employee Sentiment Monitoring Privacy Preserving Analytics, Federated Learning, Accountability Audit Trail Completeness Checks Blockchain-Based Decision Logs Unintended Harm Pre-Deployment Simulation Circuit Breaker Kill Switches Ethical Tool Stack, Bias Detection, IBM AI Fairness 360, Google What If Tool, Explainability, SHAP, LIME, ELI5, Governance, Azure Responsible AI. Dashboard, AWS SageMaker Clarify EU AI Act Compliance Checklist, 1 Risk Classification, is your AI system high risk? E.g., recruitment, credit scoring. 2. Technical file, documentation of training data, metrics, validations. 3. Human oversight, designate AI controllers with veto power. 4. Fundamental rights impact assessment, quantify effects on privacy, non-discrimination, etc. Case study, LinkedIn's Ethical AI Implementation Challenge, Algorithmic Bias in Job Recommendations Favoring Male Candidates. Solution, 1 Bias testing, discovered 30% fewer female profiles in tech leader recommendations. 2. Mitigation, debiased embeddings using adversarial learning, added fairness constraints in ranking algorithms. 3. Governance, created AI Ethics Review Board, published transparency reports. Results, gender recommendation gap reduced from 30% to 3%, 17% increase in female applicant conversions, became benchmark for ethical recruitment. AI-data governance maturity model. Mermaid Journey Title Governance Evolution Section Level 1, Reactive Ad Hoc Fixes Section Level 2, Proactive Standardized Policies Section Level 3, Managed Automated Enforcement Section Level 4, Ethical AI Ethics Embedded. Implementation Roadmap, Phase 1, Foundation, Classify data by sensitivity, public, internal, confidential, implement field-level encryption for PII, deploy data catalog with lineage tracking. Phase 2, Compliance, build DSAR, Data Subject Access Request, Portal, conduct GDPR/CCPA gap assessment, appoint Data Protection Officer. Phase 3, Ethics, establish AI Ethics Committee, integrate bias testing into ML lifecycle, create algorithm impact assessments. Phase 4, Leadership, publish transparency reports, contribute to industry ethics standards, implement ethics by design certification. Red flag, if your data scientists can't explain how models make decisions, you're one lawsuit away from an AI winter. Chapter 13 Takeaways. 1. Data quality requires automated monitoring, not periodic manual checks. 2. Privacy compliance demands engineering solutions, not just legal policies. 3. Ethical AI needs continuous bias testing, not one-time audits. 4. Trust is the ultimate currency in data-driven organizations. You wouldn't drink from a polluted river. Why base decisions on dirty data? Next, Part V explores future trends and case studies in process analytics. Part V, Future Trends and Case Studies. 14. Emerging Technologies. Core thesis, the next frontier of process analytics converges AI, IoT, and blockchain to create self-optimizing enterprises where processes anticipate, adapt, and audit themselves in real time. 14.1 AI-driven autonomous processes. The autonomy continuum, Mermaid Journey Title From Automation to Autonomy Section Level 1, Task Automation Rule-Based RPA Section Level 2, Process Intelligence Predictive Analytics Section Level 3, Contextual Adaptation Reinforcement Learning Section Level 4, Self-Optimization Closed-Loop AI Systems. Revolutionary Applications. 1. Self-healing supply chains, AI agents reroute shipments around disruptions, e.g., Maersk's real-time piracy avoidance. Tech stack, digital twins and reinforcement learning 2. Cognitive procurement, autonomous negotiation bots securing optimal terms using game theory. Example, Google's BERT-based contract analysis saving 300k hours/year 3. Adaptive manufacturing, AI controllers adjusting production parameters in real time. Impact, Siemens autonomous factory achieves 99.998% quality 2025 prediction, 40% of routine process decisions will be fully autonomous. Gartner, 14.2 IoT and real-time process analytics. The sensor revolution, Mermaid Graph TBA smart sensors B edge computing BC stream processing CD instant insights DE prescriptive actions industry transformations, sector IoT innovation. Business impact energy smart grid sensors 15% reduced transmission losses healthcare RFID enabled surgical trays 27% faster or turnaround retail smart shelf weight sensors 98% inventory accuracy agriculture soil moisture drones 30% water savings data velocity challenge, latency targets, safety critical, 10 milliseconds, e.g., autonomous vehicles, operational. 100 milliseconds, e.g., machine adjustments, analytical, ones, e.g., dashboard updates, architecture solution, edge computing processes 80% of IoT data at source shells digital twin revolution, 10,000 sensors per offshore platform, real-time analytics reducing unplanned downtime by 50%, predictive maintenance saving $4M/platform/year 14.3 blockchain for transparent process auditing the trust architecture, Mermaid Graph LRA process step B smart contract BC immutable ledger C. D tamper-proof audit transformative use cases, 1 supply chain provenance, diamond traceability from mine to retail, De Beers Trucker, food safety tracking, Walmart's pork supply chain, 2. Automated compliance, real-time ESG reporting via sensor blockchain pipelines. Example, Maersk's Tradilans cuts customs clearance from days to minutes 3. Smart contract payments, automatic invoice settlement upon IoT delivery confirmation. Impact, 98% faster payments in Siemens Energy trials performance metrics, transparency gain, 100% end-to-end process visibility, audit time reduction, 90% faster compliance verification, fraud prevention, near elimination of document tampering - convergence, AI and IoT and blockchain the Holy Trinity architecture, Mermaid Graph BTA AI intelligence controls B IoT execution B verifies C. Blockchain audit C feeds data a real-world implementation, project, pharmaceutical cold chain monitoring 1. IoT, temperature/humidity sensors in shipping containers 2. AI, predicts spoilage risk using weather and traffic data 3. Blockchain, immutable record for FDA compliance, result, reduced vaccine spoilage from 18% to 0.2%. Implementation roadmap phase 1, foundation, instrument processes with low-cost sensors, e.g., Raspberry Pi, implement private blockchain for critical workflows, train reinforcement learning models on historical data phase 2, integration, deploy edge computing nodes for real-time analytics, connect AI models to control systems via APIs, establish blockchain. Oracles for external data feeds phase 3, autonomy, implement human out-of-loop for low-risk decisions, create fail-safe mechanisms, e.g., circuit breakers, develop ethical AI governance frameworks. Risk alert, autonomy without auditability is organizational suicide. Every AI action must leave a blockchain breadcrumb trail. 2027 horizon, the self-managing enterprise predicted capabilities, 1. Anticipatory processes, predictive hiring before attrition occurs, dynamic inventory positioning ahead of demand spikes 2. Adaptive architecture, self-reconfiguring production lines, real-time organizational restructuring 3. Autonomous value chains, algorithm-to-algorithm commerce, frictionless cross-company integration. Preparing your organization, upskill teams in orchestration thinking, implement chaos engineering for resilience testing, Establish AI Ethics Review Boards. Chapter 14 Takeaways. 1. Autonomous processes evolve from rules prediction self-optimization. 2. IoT enables second-by-second process control but demands edge computing. 3. Blockchain provides the trust infrastructure for AI decisions. 4. The future belongs to companies whose processes learn faster than competitors. In the age of autonomous business, the most dangerous risk is being disrupted by your own legacy processes. Next, Chapter 15 explores real-world case studies across industries. Here are detailed case studies showcasing data analytics implementations across retail, healthcare, and banking sectors, based on verified real-world applications. 1. Retail, dynamic pricing optimization at Amazon challenge. With 300 and SKUs across 200 fulfillment centers, Amazon needed to balance real-time pricing, inventory, and delivery promises while preventing profit-eroding price wars. Solution architecture, AI pricing engine, combined machine learning, LSTM networks, with real-time data streams, demand, competitor prices, inventory levels. Buy box algorithm, prioritized sellers based on price competitiveness, 70% weight, delivery speed, and seller ratings. Automate pricing tool, enabled rules like beat competitor by 0.5% or stay above $25.99. Impact, markdown metric before AI after AI change fulfillment costs $6.50/unit $3.90/unit 40% buy box win rate 67% 99.9% 49% inventory waste $1.2b/year $0 100% reduction price changes /day 3 to 5 2,500 plus real-time adaptation source. Key lessons. Margin protection, sellers using price floors saw 23% higher profits than those racing to the bottom. Legal compliance, EU's Omnibus Directive forced transparent pricing histories to prevent gouging. Failure example, unconstrained algorithms during 2023 holiday surge raised prices by 240%, triggering customer backlash. 2. Healthcare, predictive patient flow management challenge, a major hospital system faced 40% discharge delays and ICU bottlenecks due to unanticipated patient surges. Solution architecture, IoT integration, deployed RFID tracked beds and wearable sensors feeding data to digital twins. Predictive model, XGBoost algorithms analyzed historical admissions, seasonal trends, and real-time ER wait times. Prescriptive dashboard, alerted staff about predicted bottlenecks, e.g., pharmacy overload in 90 minutes. Impact, markdown metric before AI after AI change discharge delays 40% 11% 72% nurse overtime costs $18K/month $15.3K/month 15% early disease detection 52% 77% 48% ICU mortality rate 8.2% 6.1% 25% source. Key lessons, ethical safeguards, anonymized data to prevent bias against elderly high-risk patients. Workflow integration, reduced false alerts by 60% by embedding predictions directly into AIR systems. ROI insight, predictive maintenance on MRI machines cut downtime costs by $4M/platform/year. 3. Banking, fraud detection at JP Morgan Chase challenge. Rising digital transactions caused fraud losses of $12 billion industry-wide in 2024, with legacy systems generating 85% false positives. Solution architecture, AI fraud nets, deployed ensemble models, isolation forest and graph neural networks, to analyze 1.1 M transactions/hour. Behavioral biometrics, tracked keystroke dynamics and mouse movements to flag account takeovers. Blockchain auditing, immutable logs for transaction trails to meet GDPR/CCPA requirements. Impact, Markdown metric before AI after AI change false positives 85% 35% 59% fraud detection speed 48 hours 87 milliseconds 2mx faster annual savings, $1.2 billion direct cost avoidance customer rejection rates 20% 4% 80% source, key lessons, explainability, used CHAP values to justify fraud flags to regulators, avoiding $230 million in fines. Continuous learning, model retrained weekly with adversarial attack simulations. Collaborative defense, shared threat patterns with Bank of America, boosting industry-wide fraud catch rates by 30%. Cross-industry insights from case studies 1. AI-human symbiosis, Amazon's pricing teams override algorithms during PR crises, e.g., natural disasters. JP Morgan's fraud analysts fine-tune AI thresholds quarterly to avoid algorithmic rigidity. 2. Ethical governance, healthcare models excluded zip code data to prevent socioeconomic bias in treatment plans. Amazon's EU compliance required 30-day price histories to prove fair surge pricing. 3. Tech stack convergence, all three used hybrid cloud edge architectures. Amazon's real-time pricing required 100 milliseconds latency, while JP Morgan processed IoT biometrics at branch terminals. The future belongs to systems where AI predicts, humans contextualize, and ethics govern. Synthesized from case study outcomes. For implementation blueprints, retail, start with price floors/ceilings before full automation. Healthcare, prioritize IOMT integration for continuous vital monitoring. Banking, deploy behavioral biometrics layered with transaction NLP. Part B, Future Trends and Case Study 16. The Future of Process Analytics Core Thesis. Process analytics is evolving from reactive insights to autonomous optimization, but scaling this future requires conquering ethical, technical, and human capital challenges. 16.1 Hyper-automation and the self-optimizing enterprise. The 2030 architecture, Mermaid Graph LRA IoT sensors B Edge AI BC autonomous decision CD blockchain audit trail DE continuous learning EA key components of self-optimizing systems, technology function real-world example digital process twins live virtual replicas of physical operations Siemens autonomous factories reinforcement learning AI agents learning optimal paths through trial/error Google's data center cooling, 40% energy savings, algorithmic governance smart contracts enforcing compliance Maersk's automated customs clearance neural process mining AI discovering hidden process patterns Celanese process intelligence graph projected economic impact, McKinsey 2026, 45% reduction in operational costs, 30% faster innovation cycles. $12T global GDP boost from productivity gains 16.2 critical challenges and mitigation strategies 1. Bias mitigation in autonomous systems the bias detection framework, Mermaid journey title bias safeguard workflow section data collection diverse sampling section model training adversarial debiasing section deployment continuous drift monitoring section audit blockchain explainability logs proven solutions, data diversity, synthetic data generation for edge cases, algorithmic fairness, integrated bias scores, e.g., IBM AIF 360, human oversight, ethics hot switch override. Capability, case, LinkedIn reduced gender bias in job recommendations by 90% too. Scalability at the fractal edge the scaling paradox, processing 1M IoT events/SEC requires rethinking architectures next-gen solutions, challenge emerging technology pioneers data velocity neuromorphic computing Intel Loihi chips energy efficiency quantum-inspired algorithms Fujitsu digital annealer latency sensitivity 5G plus edge AI chips NVIDIA Jetson Orin Cross Company. Integration industry cloud ecosystems Microsoft Industry Clouds 3. Talent gap, the 4M workforce strategy closing the skills gap, Mermaid Pi title talent development mix upskilling, 40 automation, 30 new hires, 20 gig experts, 10 action plan, upskilling, VR simulation labs for process optimization, Automation, AI copilots, e.g., Microsoft Copilot for Power BI. Education, university partnerships for autonomous systems engineering degrees. Gig economy, blockchain verified skills marketplaces - industry specific futures manufacturing. 2030, self-reconfiguring assembly lines adapting to component shortages, predictive material ordering via satellite supply chain monitoring healthcare. 2027, AI triage nurses with 98% diagnostic accuracy, blockchain-enabled patient data sovereignty finance. 2028, algorithmic CFOs managing real-time treasury operations, quantum-resistant blockchain settlements - preparing your organization 5-year roadmap, Mermaid Gantt title self-optimizing enterprise journey date format YYYY section. Foundation IoT Instrumentation 2023, 12MO Data Governance Upgrade 2024, 6MO Section Intelligence AI Process Agents 2024, 18MO Blockchain Audit Layer 2025, 12MO Section Autonomy Closed Loop Optimization 2026, 24MO Ethical AI Certification 2027, 6MO Immediate Actions, 1 Conduct Autonomy Audit, Readiness Score equals, Data Quality times 0.3, plus, Tech Maturity times 0.4, plus, Culture times 0.3, 2. Launch Pilot, start with non-critical process, e.g., IT ticket routing, implement reinforcement learning with human in the loop. 3. Build Ethics Council, include ethicists, frontline workers, customers. The ultimate challenge, human relevance. The new workforce equation, math human \value equals \frac creativity \times \judgment automation potential future-proof skills, orchestration thinking, managing AI agent ecosystems, ethical reasoning, making value-based oversight decisions, chaos engineering, stress testing autonomous systems. In 2030, the highest paid employee will be the process ethicist who keeps our AI from optimizing itself into oblivion. Chapter 16 Takeaways. 1. Hyper-automation converges AI, IoT, and blockchain into self-optimizing systems. 2. Bias mitigation requires technical solutions and cultural vigilance. 3. Scalability demands neuromorphic computing and industry clouds. 4. Talent strategy must blend upskilling with AI augmentation. 5. The end game isn't eliminating humans, it's elevating human potential. The goal isn't autonomous processes, it's autonomous enterprises that free humans for higher purpose. Final thought, as we stand at the dawn of the self-optimizing era, remember, technology amplifies our values. Choose yours wisely. Appendices - A glossary of key terms, term definition, chapter reference -- process mining technique, analyzing digital event logs to discover, monitor, and improve processes. 3. 12 digital twin virtual replica of physical processes enabling simulation and optimization. 5. 14 hyper automation end-to-end automation combining RPA, AI, and analytics tools. 16 Prescriptive Analytics recommends optimal actions based on predictions and business constraints. 6 ML Ops practices for deploying and maintaining machine learning models in production. 5. 12 SHAP values framework explaining AI model outputs, Shapley additive explanations. 13 Data Fabric unified architecture integrating disparate data sources. 12 IoT edge computing processing sensor data locally for real-time decisioning. 14 Process conformance measurement of actual workflows versus designed procedures. 3. 13-B Process Analytics Implementation Checklist. Phase 1, Foundation Setup, conduct process discovery workshops with stakeholders, inventory data sources, ERP, CRM, IoT, legacy systems, define 3 to 5 high-impact KPIs, e.g., cycle time reduction %, select core tools, process mining and by platform. Phase 2, pilot execution, map as-is process with mining tool, Celanese/UiPath, build descriptive dashboards for bottleneck visualization, develop 1 to 2 predictive models, e.g., churn/failure risk, implement data quality monitoring, completeness 95%. Phase 3, Scaling and integration, connect insights to automation tools, RPA/IPA, establish model retraining cadence, bi-weekly/monthly, launch data literacy certification program, create bias testing protocol for AI systems. Phase 4, continuous optimization, implement closed-loop feedback, e.g., bot analytics bot, conduct quarterly ROI audits, run process hackathons for improvement ideas. See recommended tools and frameworks category. Commercial tools, open source alternatives, specialized solutions. Process mining, Celanese, UiPath process mining, Prom, Disco Minute, QPR process analyzer by visualization, Power BI, Tableau, Click Metabase, Apache Superset, Sigma Computing, ThoughtSpot ML platforms, DataRobot, Azure ML, SageMaker, MLflow, Kubeflow, H2O.ai, Domino Data Lab Automation, UiPath, Automation Anywhere Robot Framework, N8 and Workato, Pega Data Governance, Collabra, Alation, Apache Atlas, Open Metadata Informatica, Axon, Tailend DQ IoT Analytics, AWS IoT Analytics, Azure DT Node-RED, Thingsboard, Lozant, Crosser.io, Blockchain Audit, IBM Blockchain Platform, Hyperledger, Fabric, VeChain, Toolchain, R3, Corda-D, Implementation Risk Matrix, Markdown Risk Probability Impact Mitigation Strategy Poor data quality, high implement automated validation pipelines, tool integration, failure medium high, conduct API stress tests before deployment, employee resistance high medium, CO create solutions with frontline teams, regulatory non-compliance low high, embed privacy by design, GDPR/CCPA, model bias escalation medium high, monthly bias testing and ethics reviews. Quick ROI calculator formula, math \begin align \text ROI equals and \text, process efficiency gains times hourly cost, \and plus \text, revenue impact from improvements, and \text, tool costs plus implementation labor, \and align example inputs, time saved, 10 HRS/day times $50/HR equals $500/day, error reduction, 50 fewer defects/day times $100/defect equals $5,000/day, tool cost, $15,000/month, monthly ROI, $500 plus $5,000, times 22 days, $15,000 equals $116,000. F Learning Pathway 1. Foundational Courses, Coursera, Process Mining by Eindhoven University, edX, Data Science for Business, MIT, 2. Certifications, Celanese Process Mining Consultant, Microsoft Power BI Data Analyst, Google Cloud Professional ML Engineer. 3. Communities, Process Mining Camp, Annual Conference, r/process mining on Reddit, International Association of Process Professionals, IAPP, the perfect implementation doesn't exist. Start with one process, prove value, and scale relentlessly. Final note, these appendices equip you to operationalize concepts from this book. Remember, tools enable, but people transform. Invest equally in technology and talent.